Here, in the simple terms, expectation means we can say mean, or in other term you can say average. Okay, so here you can take this formula. Let x be a discrete random variable with probability mass function p x equals to x. Then its mathematical expectation is denoted by E of x and is by the formula mu equal to E of x, that is equals to summation over all x into p, that is x equals to x. For a discrete, your mu or mean equal to summation over all x into px. Now, if x is a continuous random variable, then random variable with, you can say, PDF probability distribution function fx, then its expectation is given by same thing, mu equal to E of x equal to integration minus infinity to plus infinity x into fx dx. Okay. For a discrete, we have summation over all x px, and for a continuous, we have integration x fx dx. Now knowing this, let's solve one example. You write the question first. For example, if you say, suppose when a car is washed, an attendant is paid according to the number of cars that pass through. Now suppose the probabilities are 1 by 12, 1 by 12, 1 by 4, 1 by 4, 1 by 6, and 1 by 6 respectively. That are the attendant receives rupees 70, 90, 110, 130, 150, and 170 on any Sunday. Now the question is, find the attendant's expected earnings for this particular day. Okay. Now see here, probability are 1 by 12, 1 by 12, 1 by 4, 1 by 4, 1 by 6, and 1 by 6, and the received amount is 70, 90, 110, 130, 150, and 170. Now we have to find the expected earning of that attendant. Okay. So for answer part, So for solution part, you can look here. For solution part, we are saying let x be a random variable which assumes the attendants receiving a particular amount with the given probability. Now, as it is a discrete one, we can represent it as a distribution. So, it can be given as a distribution or probability distribution. So, the probability distribution of x is given by, look here I am writing x equal to x, or here p of x equal to x. So here 70, 90, 110, 130, 150, and 170. Look here, for 70 the probability is 1 by 12. For 90 it is 1 by 12. For 110 it is 1 by 4. For 130 1 by 4. For 150 1 by 6, and 170 1 by 6. So corresponding to the amount, we have to write the probability value. So probability x equal to 70 as 1 by 12. For probability x equal to 90 as again 1 by 12. 1 by 10, 110 as 1 by 4. 130 as 1 by 4. 150 as 1 by 6, and 170 as 1 by 6. Now, after from this table, from this probability distribution table, you can have the expected earning of the attendant are, look here, E of x as summation over all x into p of x equal to x. So simple, 1 by 12, x is 70, probability x is converted, so 70 into 1 by 12 plus 90 into 1 by 12 plus 110 into 1 by 4 plus 130 into 1 by 4 plus 150 into 1 by 6 plus last 170 into 1 by 6. Okay, so the value is nothing but here 5.833, here 7.5 plus 27.5 plus 32.5 plus 25 plus 28.33. Okay, so this value is nothing but 126.66. Okay, hence you can say hence the attendance expected earning for this particular day is how much? 126.66. Clear to all? Hello? Is it clear to all?
Yes, sir.
That was simple, huh? The value x into p of x, just multiplying and adding. This will give you the expectation, or simple, you can say average value or mean value. Okay. Now, similarly, there is another example. Another example for continuous one. Okay, now you take another example. It says the probability distribution of the discrete random variable x is, suppose fx equal to, look here, 3cx 1 by 4 to the power x, 3 by 4 to the power 3 minus x. Here x equal to 0, 1, 2, 3. Okay, then question is find the mean of x. Question clear? Look here, fx is given as 3cx. Cx means a combination, permutation, combination. Okay, 3cx into 1 by 4 to the power x into 3 by 4 to the power 3 minus x. Here x equal to 0, 1, 2 and 3. And question is we have to find the mean of x. So for answer part, simple one, you just write the probability distribution. Okay, so the probability distribution of x is given by, look here x equal to x and below p of x equal to x. So for x equal to 0, what will value? You put the value of 0. So देखो 3c0 1 by 4 to the power 0, 3 by 4 to the power 3 minus 0. So 3c0 is 1. 1 by 4 to the power 0 is 1, and this is 3 by 4 to the power 3. So here x equal to x for 0, it gives 3 by 4 to the power 3. Similarly, for x equal to 1, what do you take? For x equal to 1 क्या होगा देखो, 3c1 1 by 4 to the power 1 and 3 by 4 to the power 3 minus 1. So 3c4 का वैल्यू है 3 factorial into 2 factorial 1 factorial, or this is 3. Here 1 by 4 and 3 by 4 to the power 2. So as a whole you can say देखो 3 into 3 square, that is 3 cube, and below 4 3 by 4 to the power cube again. Similarly, for x equal to 2, what do you value? Which value? For x equal to 2, look here, 3c2 1 by 4 square, 3 by 4 to the power 3 minus 2. So 3c2 how much? 3c2 3 factorial, 2 factorial, 3 minus 2, 1 factorial, or 3c2 is nothing but 3, 1 by 4 square and 3 by 4 power 1. So which gives 3 square, or simply you can say you can say 1 by 4 with 3 by 4 square. Or similarly, for x equal to 3, you take 3c3, that is value is 1, 1 by 4 power 3 into 3 by 4 power 0. So this gives only 1 by 4 power 3. Okay. This is value for our probability distribution value. Now just apply the formula. The mean of x is, we have to find mu. So mu equal to e of x, that is equal to summation over all x with x into p of x equal to x. So just simply multiply. So 0 into 3 by 4 power 3, 1 into 3 by 4 cube, 2 into 1 by 4 into this, plus 3 into this much. Or simple, you can say 0 into 3 by 4 cube plus 1 into 3 by 4 cube plus 2 into 1 by 4 into 3 by 4 square plus 3 into 1 by 4 cube. So this gives, just simple calculation, this gives 0.421875 plus 0.28125 plus 0.046875, or as a whole this gives 0.75, right? Hmm? Is it clear?
Yes, sir.
Okay. Now here, चलो extra लिखते हैं. Now next thing is some properties of expectation. Okay, here first is, if x and y are random variable, then e of x plus y equal to ex plus ey, provided the expectation exists. This is the first property. Expectation of x plus y is ex plus ey. Now second property is the mathematical expectation of the sum of n random variable is equal to the sum of their expectation, provided the expectation exists. That means if you have n number of random variable, or in the simple way you can say e of x1 plus x2 plus up to xn is equal to something e of x1 plus e of x2 plus up to e of xn. Okay. Now the third one is important one. If x and y are independent random variables, then you can say e of x into y equal to ex into ey. That means if two random variables are independent, then expected value of their product is equal to product of the expectation. Okay. Similarly, the fourth one is, if x is a random variable and a is a constant, then you have e of expectation of a into fx is equal to a into e of f of x. That means you can take the constant term outside, and for linearity you have e of fx plus a as e of fx plus a. Okay. Next, combining of all these, you can have, if x and y, okay, if x is a random variable and a, b are constant, then you have expectation of ax plus b equal to a e of x plus b. Okay, but provided the expectation exists. Okay, These are the certain properties of mathematical expectation. Is it clear to all? Hmm? Hello?
Yes, sir.
Okay. जस्ट इसको लिखो, आई वांट टू रिमूव इट. सब लिखे ना? Have you written all these things? Or you can take a snapshot also, no problem. ठीक है, इसको मिटाना है मुझे. Okay, next. Hmm? Next one is variance. एक minute. Next one is variance. Variance of x. Here you can say let x be a discrete random variable. We can say the variance of x, which is denoted by v of x, is given by, you can say, v of x equal to e of the x minus e of x, or simply you have expectation of x minus mu, or here square. Okay, expectation of x minus mu square. That means if you break it, then you can get e of, look here, x square plus e of x square minus 2 into x into e of x. Now, applying the properties, you have e of x square plus e of x square minus 2 e of x into e of x. So, we have simply e of x square plus e of x square minus 2 e of x square. Or in the simple way, we have v of x equal to e of x square minus ex square. Okay. Variance of x equal to expectation of x square minus expectation x whole square. Okay. You can take this one. So from here we have certain properties of variance. Certain properties. Look here, first property. If x is a random variable, then we have v of ax plus b equal to a square vx, where a and b are constants. Okay, look here. If x is a random variable, then variance of ax plus b equal to a square into v of x. Now, just proof. First proving it, you can say let y equal to ax plus b. So we need to find e of y. E of y equal to e of ax plus b. Now, as we know the property of expectation as a linear property, this the fifth property, the property which we discussed. So this value is nothing but a into ex plus b. Now, now you can simply do y minus e of y. This gives a x minus e of x. Okay. So if we square both sides, squaring both sides, squaring both sides, what do we get? We get that y minus ey square equal to a square x minus e of x square. Now, applying expectation both sides, what do we get? E of y minus ey square as e square e of x minus ex square, or this is nothing but our variance v of y equal to a square v of x, or simply we have v of ax plus b equal to a square v of x. Okay, you take this formula, in future it will applicable. V of x plus b equal to a square into vx. Okay. Just write it, everyone. ओके, चलो नोइंग दिस एक एग्जांपल सॉल्व करते हैं. Example: the random variable x representing the number of errors per 100 line of software code has the following probability distribution. Which one? Look here: x, fx, 2, 3, 4, 5, 6. Here 0.01, 0.25, 0.4, 0.3, and 0.04. This represent the number of error per 100 line of software code has the following probability distribution. Means two error has a probability 0.01, 3 error has a probability 0.25, 4 error has a probability 0.4, 5 error has a probability 0.3, and 6 has a probability 0.04. Now 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 we want to find the variance of this distribution. So you can say we know the variance has the formula v of x as e of x square minus e of x square. Now first part is you have to compute e of x square. As usual, we know the formula for e of x as summation over x into p of x equal to x. So if you want to find value of e of x square, then the formula is nothing but same: x square p of x equal to x. So simple. We have to do x square into probability. That means 2 square into 0.01 plus 3 square into 0.25 plus 4 square into 0.4 plus 5 square into 0.3 plus 6 square into 0.04. Or this gives 0.04 plus 2.25 plus 6.4 plus 7.5 plus 1.44, or the value is nothing but your 17.63. Okay, this value is e of x square. Next part, you have to find e of x. Next, e of x as summation over all x p of x equal to x, or simply you have 2 into 0.01 plus 3 into 0.25 plus 4 into 0.4 plus 5 into 0.3 plus 6 into 0.04. This value is 0.02 plus 0.75 plus 1.6 plus 1.5 plus 0.24. So the whole value is 4.11. Now you apply the formula. Now v of x equal to e of x square minus ex square. So e of x square is 17.63 minus 4.11 square. Or this value is 17.63 minus 16.8921, or this value is 0.7379. Right? ओके, ज़्यादा कुछ नहीं, देखो we have to compute v of x square equal to e of x square minus e of ex square. Ex means mean. Already you have computed, or you can have the simple formula. For e of x square, you can take e of x square is solution or will have x square p of x. That means nothing but your x square into this plus x square into this plus x square into this plus this into this. Okay, these are all about your variance. Next class we deal with some more example, and we go with standard deviation and all these things. Okay, everyone, is there any doubt?
No, sir.
No, sir.
Okay, chalo. Thank you. Huh?
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.